Imagine retrofitting your school with a new heating system that would allow you to add cooling, individual temperature and ventilation controls, a system that would improve classroom comfort for your faculty and students. Imagine a system so beautiful in its simplicity that your janitorial staff can maintain it. Imagine a system that would allow you to disconnect your heating gas hookup forever. Imagine having these improvements with no increase in your operating cost. Our geothermal systems have achieved these performance requirements for a number of schools, and we're confident we can achieve similar results for your school. The key to our geothermal system lies in recycling heating and cooling energy. Mass, thermal conductivity, and moisture are key when these properties allow us to recycle heat energy in a highly efficient way. The system is remarkably simple. A vertical heat exchanger matrix is buried in the earth. This matrix acts as a storage battery or energy capacitor for heating or cooling energy. Water temperature within the matrix is moderate because it's in indirect contact with the surrounding earth. Water from the heat exchange network is circulated through the school building in a single closed loop. In cold months, water in this closed loop is much warmer than outside air temperatures and is a useful heat source. Heat is drawn from this circulating water by the room heat pumps and used to warm the air in the building. In warmer months, water in the closed loop is cooler than the outside air. Heat is drawn from the air within the building by the room heat pumps and is exchanged to the circulating water. Heated or cooled water then returns to the underground matrix, where it quickly exchanges energy with the water circulating there. All ground-coupled heat exchange systems work on this principle, but most conventional designs are far too complex and expensive. In a typical system, ground loop water is circulated via numerous zone loops. These designs require more pipe, more fittings, more pumps, and are typically outfitted with computerized controls and sensor systems. This complexity adds a lot of initial cost and maintenance expense, but not a lot of value. In our one-pipe design, groundwater circulates around the perimeter of the building in a single large loop. Heat pumps are installed along this loop so that energy can be drawn from or recycled to the loop where needed, when needed, and in the amount needed. Here's a typical classroom installation, with our groundwater loop pipe here and the unit mounted below it here. These units have proven highly successful. They are quiet and efficient. Teachers are no longer forced to accept a single temperature for the entire building. Now they can set their classroom temperatures individually. Year-round comfort levels are dramatically improved. The unit controls can be coupled to the room's light switch. When the lights are turned on in the morning, the heat pump goes into action, bringing the room to desired temperature in about 15 minutes. At the end of the day, the lights are turned off, and the unit automatically returns to setback mode. This system brings another major advantage to the classroom. Its quiet operation and improved comfort allow better communication between teacher and student, improved attention spans, and they create an indoor environment suited to better educational outcomes for the students. Administrators and school districts appreciate all these benefits, and they appreciate its low first cost, low operating cost, and ease of maintenance. With less piping, fewer fittings, and simplified controls, our one-pipe system can be installed for about half the cost of a typical geothermal system. And our simple design contributes to very easy maintenance. Annual utility bills can be dramatically lowered. Our client schools have been able to reduce their consumption of energy by as much as 70%, and several have completely eliminated their natural gas hookups. Quiet, comfortable, efficient, and cost-effective. Imagine all these benefits in your school. Imagine a one-pipe geothermal system.